In this lecture, we're going to add a little bit of extra code to make the cars turn away from each other if there's a collision, and this code will help cars pass each other as well. So what we're going to do is take the capsule point or our tracker point that we're trying to drive to and move it by a certain offset if we detect a collision. So let's take the car that's behind in this case. When it runs into the car in front of us, it's going to trigger a collision in both cars. Script on both cars is going to recalculate a new goal position that is based on the tracker position plus a bit of an offset. And what it's going to do is going to make one car turn in one direction and the other car turn in the other direction, which will give you some really interesting avoidance dynamics with relatively simple code. And what we're going to do is use the colliders and the rigid body that's already on the car. The little tiny issue that we have is that our AI script isn't on the game object with the rigid body. So we have to write some collision script that we put on the rigid body and then get that to talk to our AI controller. Right, so let's get stuck into it. Okay, so we're going to create some new script which we will attach to the rigid body of our vehicles. Okay, so let's go create C# script, and I'm going to call this avoid detector. Now let's open that up, and inside of here we need a few public values at the top because we want to pass them back to our AI controller code. First of all, we're going to create a public float, call it avoid path, and that's going to be the offset that we're setting. And then we want a public float avoid time. Now we're going to program this so that once you've hit the car, you then go into this different kind of sequence of following, and you start for a certain amount of time avoid the car in front of you rather than be so concerned of staying on your particular path. But because the avoid path is actually calculated based on where your tracker is, you will kind of still be going in the right direction. You'll just be sort of going out a little bit wider than necessary, so for a certain amount of time. Okay, so you might just go into avoid mode for like 1 second or 2 seconds, and then you go back to following the waypoint tracker again, unless of course you collide. Okay, so there's the avoid time. Now also going to add in a public float called wander distance. And this will be how much room you give yourself to go past the car. I've made this public in this case so that you can actually set it in the inspector. So the bigger the number, the wider the distance you're going to put between your car and the other car. Okay, and so therefore you can change it for each individual car. If you have a car that's really aggressive and wants to be very close to other cars when it passes, then you might make it a much smaller value. Of course, you can't set it to 0 because then you're not giving your car any chance whatsoever to get past because you're not providing any space. Okay, and then we also need a public float avoid length, and this is how long you're giving the car to go into that avoid mode. So we'll start off with 1 second. Okay, so let's just write 1 second here as a comment so that you can remember what that is. And I'm going to put let's see, avoiding distance in here. Yes, I know it's very unusual to see me writing comments in my code, but yeah, sometimes you just come back to things and go, what was that? And it just helps. Okay, so first of all, we don't need these. Let's get rid of our start and our update. And we're going to create a void on collision stay. Collision col. Now that's going to receive the collider of the object that we've bumped into, which is going to be the other car. Now just to make sure that it is another car, let's put if collider or col.gameObject.tag does not equal car, then we've actually bumped into something else. And in this case, we're going to just return and not take any notice of it. All right, so the actual code, let's go rigid body, other car equals what we collided into, dot rigid body, and avoid time equals time dot time, so the time it is now, plus the avoid length. So that when time.time reaches avoid time, we can go back to normal pathfinding as we did before. Okay, so vector 3, other car local target is going to equal the local position of the car you've bumped into relative to yourself. And this is exactly what we did with the waypoints and the waypoint tracker. We're getting their local offset. Okay, so it's going to be a transform dot inverse transform point of the other car dot game object. Now that should be other car, not other car local target. Dot game object dot transform dot position. And then we're going to create a float to work out the angle to the other car. Exactly the same thing that we did before with our progress tracker and waypoints. So other car angle equals mathf.atan2 other car local target dot x and other car local target dot z, and then we can set avoid path to equal wander distance multiplied by the angle. So we'll put a minus mathf dot sign, so we're actually turning in the opposite direction of the angle to the car, which makes sense. So if a car is on one side of you, you want to turn in the other direction. So other car angle. Now don't forget that this code is going to fire on both vehicles involved in the collision, which means that one will get a turn to turn in one direction and the other will get the turn to turn in the other direction. So no, it doesn't matter who initiates the collision, they're both going to go into this on collision stay method and keep running this for each other, looking at the opposite car. Right, so this is setting our avoid path and our avoid time, and those are the two values we will use back in our AI controller. Now, when the collision is over, we want to set them back to 0. So void on collision exit, collision col, and then inside of here, we're going to test that we're dealing with cars. And then avoid time equals 0. Now I'm not setting avoid path to be 0, though I guess you could, because in the AI controller code, we're only going to test if there is avoid time to actually perform an avoidance with. That's when we will do this. So it doesn't matter what avoid path is, and it will get reset next time so there's a collision. Right, so save that. Now we're going to go back into Unity. There's two things we're going to do here first. We want to go to our Jeep or your car and get the car body, so the object that has the rigid body on it. Very important, or however many rigid bodies that you've got. The same one that has the flip car and the anti-roll bar on there, and you want to drag and drop your avoid detector onto that. Now, if you followed along with me previously and you added a copy of your other car, and I've got 2 purple Jeeps here, you want to go to that car body as well and drag and drop your avoid detector onto there. Okay, so it's very important that we keep these prefabs the same, and I've got 2, so I don't need to keep saving my prefab back at this point. It's not going to get out of control as long as I remember to keep adding the code into the right places. Right, so the other thing that we need to do is tag the objects that we're colliding into. Now, we don't want to tag the top level object. It's got to be the object that has the collider on it and the rigid body. So select your car body and go to the inspector for the tag, drop that down. You'll have to add a tag because there won't be one for car, and then save that. Then select our car body again and then tag that as car, and find your other car body and tag that as car as well. The spelling of your tag is very important, that it's exactly the same as you have the spelling in your code. So if it's lowercase car, then you want lowercase car in your script. The next bit of code to put in is in our AI controller. So let's open that up and we're going to go down into our update. The things that we're going to change are our local target and our target angle, because they're the ones that are going to change if we're in avoid mode. So what I'm going to do here is just copy that and I'm going to put it down here. First of all, let's put in an if statement to see if we should be avoiding things. So if time.time is less than our drive script dot rigid body dot get component, and we get our avoid detector and we get the avoid time. If we're still in avoid time, then we're going to obviously go to a different local target, and I'll come back to that because I just want to tidy up this else. So else, it will be the values that we were calculating before. Now we're going to declare these outside of the else statement, so we just get rid of our vector3 and our float values for that. And then for these values at the top, we can just actually get rid of all of the math in there because we're just declaring them. Okay, so now what goes into here? Well, we're going to have local target equals tracker.transform.right multiplied by our offset or our avoid path. So ds.rb.getComponent avoid detector, and that will be .avoid path. And then target angle equals math f dot a tan 2, and that will be again local target dot x local target dot z multiplied by mathf dot rad 2 deg. And I've just realized that this line and this line are exactly the same, so we could actually grab this line and cut it out of there, paste it down there, and just delete it out of there, so that now all we're doing is just changing our local target. All right, so let's save that and we'll try it out. To see it in action, you'll probably want to change the speed of your cars. So my first car, which is the one I have the camera following, which is the one we've always been using, I've turned down the maximum speed to 30 over in the inspector. The other one, if we have a look at that and click on it, I've got its maximum speed at 250. So that should allow us to see this overtaking happen and what happens when they bump into each other and the direction that they turn away from each other. So let me just get in a little closer in here. So it should be happening in this first little straight. So that's why I've slowed this first one right down. And they're going to turn away from each other. Now, if you don't think the avoidance time is long enough, then of course you can fix that. So let's have a look at this car as it comes up and it bumps into the back. See how this car is turning away and constantly turning away? And then at some point, the other car actually gets a chance to cut it across on the inside. Now, this one is stuck trying to speed up and catch up to its tracker now that it has lost its direction, because it's kind of stuck using the physics on this barrier here. and so for it's being pushed around on that curve and it can't actually catch up to its tracker. But eventually, when it's pushed enough, which is around here, it's going to get going again. So it was really decently stuck on that part. And now the other car has a massive lead. Okay, so that is passing, and the relatively easy way to implement that. If you want to try it out with even more cars, then now that you've got these Jeeps, they're pretty much finished. They can almost become a prefab, but we can just Control D to make another one and then find where that went to and hit the W and bring that over there. And why not add another one? So Control D and we'll put this one over here. Okay, so all those last ones I made are all gonna go at 250, so this will be interesting. Can't promise there will not be a pile-up. Let's have a look. So what you can tell from this is that the difference between the cars is really going to make a huge difference in the whole dynamics of the whole racing game. Okay, so there is kind of a bit of a pile-up going on over in this corner. And the reason being is that they're all sort of still colliding with each other. And here we go, one's finally broken free and it's back on its tracker. And eventually these will as well, and there goes that guy's out of it and he's gone, and the other two are stuck. Now these ones that are stuck will eventually become unstuck, as you can see they are, which is fine. But what we're going to work on in the next lecture is a little bit of script, pretty much like the flip car script, that if a car does really get stuck, so like it runs into a wall and it's just stuck there for quite a while, we want it to reset to the previous waypoint. So we will do that in the next video.